Jeremy, welcome to the OfferZen podcast. It's so nice to have you here, but also be in the country. You've traveled from quite a distance.
Yes, from California, and it's my first time in Africa, and it's been awesome so far. So
cool. It's nice.
Thank you for having me.
Inaugural studio session on the African continent. That's quite a cool thing. So for people who don't know, and I hope you don't mind the flattery from my side, but you've
I'll have to correct you afterwards.
Please do. You've co-founded Cloud Native. You've worked as like a chief and lead technologist at Reddit. You've been the founding reliability engineer at Netflix. If I'm not mistaken, you've also produced some episodes of Cyanide and Happiness, and you've won Emmy Awards for that.
No, I won my Emmy Awards for my work at Netflix, along with 1,000 other Netflix engineers, just to be clear.
Cool.
Yes. I just think it's funny to put 3-time Emmy Award winner on my LinkedIn profile, since technically I am.
Yeah.
In the most technical sense of the word.
Still quite an impressive CV to beat. That's quite a cool little list of things
Thank
you've got there. And you obviously have your own company now, MinOps, as well.
Yes.
Before we jump ahead, I'm keen, what's the story behind Cyanide and Happiness? Because I remember from just being on Tumblr in 2008, that was something I saw a lot of.
So Cyanide and Happiness, for those who don't know, is a cartoon that's not safe for work. So you should check it later if you're at work. And it's written by these 4 guys, and one of them lived in Ireland at the time. I think Ireland. Pretty sure it's Ireland. Not in the United States. And he wanted to come to the United States to be with the other guys. And the immigration to the United States, as you know, is not easy. The best way to get to the United States and stay is to get an O1 visa, which is somebody who is an extraordinary person in some specific field. So this is what actors and artists and things like that get. And so since he's an artist, he wanted to get that visa. To get that visa, you have to prove that you are a famous, well-known, talented artist and extraordinary in your field. So I helped him by making some posts on Reddit for him, and posting some ads up to help him get his visa by having everyone on Reddit sign a petition to have him enter the United States. And so he got his visa. And so as a thank you, I got to help produce when they made TV shows. It was more of an honorary credit. I didn't really do anything other than help him out. But still I got an honorary producer credit, which did get me an IMDb profile. So, that's kind of cool, I guess.
Yeah, I mean, it's nice when you Google Jeremy Edberg, you have the LinkedIn, but then IMDb comes up as well. It's
exactly.
Quite a cool, mix of things.
Yeah.
Has anything interesting or unexpected come from having produced Cyanide and Happiness? You didn't get
One, actually, very interesting thing did happen. When I left Reddit, I made a blog post, and then I was getting a bunch of emails from people who were like, hey, you should come work here, blah, blah, blah. But I got one very interesting one. I got an email from somebody who said, I want to remake the Star Wars prequels without Jar Jar. Are you in? And that was the entirety of the email. And my first thought was, why in the world would you think I'd be interested in that? Until I realized, I have that producer credit.
Yeah. Did you ever follow up with that?
I was like, how do you plan to get around the copyright issue? And they never emailed me back.
Probably just taking his chances, but that's quite a cool little... I want to frame that email.
But that was pretty funny.
Yeah. Amazing. I mean, we could probably talk about any one of those accolades of yours for a while. But something which I really wanted to...
I'd rather we didn't.
Cool. Something which I really wanted to zoom in on, based off of the conversation we had last time we spoke, was this constraint that you had while you were working at Netflix as the reliability engineer, around, or you had to, that solution you had to engineer for that constraint. But maybe we can just start with giving an idea of what your role at Netflix was during the time of that constraint that you were facing, and then just sort of set the scene. What was that constraint? What was the problem you?
Yeah. So when I came to Netflix, you got to remember Netflix delivered DVDs through the mail for the first 10 years of its life. Most people outside the US don't even realize that Netflix started as DVD by mail.
Yeah.
And so at the time, if the website was down for 2 or 3 hours, nobody cared. I mean, they cared a little bit, but you just went and added your movies to your queue later. It wasn't a huge deal. And so when Netflix started to do streaming, it was just for free along with your DVD plan at first. But we had no way of knowing if streaming was even working or not. The only way we would know is people would call in customer service and complain that they couldn't stream. That was the entirety of the alerting system at the time. When I got to Netflix, I actually got there as the first reliability engineer, and there was supposed to be a manager who was starting at the same time, but because of some personal issue, he was not able to start.
Yeah.
So I ended up having to like kind of be the manager, but not really be the manager, along with my director. And so ended up in this weird position of sort of managing, but not really. And so that's where we started. And then I was working with the other people on the monitoring team, which had just started up a few months prior. And so they were just starting to build out a monitoring system. And so when we started, the first thing we did was we said, well, it would be great to know if streaming was actually working.
Yeah.
So let's maybe build some alerts and some monitoring for this. And the monitoring system already existed at the time. And we were able to do the monitoring, but we had no alerting. So that was like the first thing that we built. And then the next thing that we built was, okay, when something is broken, at the time, you had to call whoever it was that was responsible for that thing to get it fixed. But you just had to know who to call. There was no like chart. There was nothing that said, this is who you call for this. You just had to know that Bill was responsible for that and John was responsible for that. And that was the extent of, so everybody had to learn this when they got there. And so that was another big thing that we've tried to fix by essentially creating a system that said, push this button to call whoever is responsible for that service. And then it was up to the service people to register themselves as responsible. We eventually tied that into our alerting system, our paging system. We used PagerDuty. So you literally just pushed a button to say, page whoever is on call right now for this service. But yeah, that was basically it. We didn't have any way of knowing when the site was down. We didn't have a good way of contacting people once we figured out that it was down. We didn't have any good way of diagnosing where the problem lies or anything like that, because the company was built around this. The website is important, but not the most important thing.
Yeah. And that was obviously the shift when you moved from not doing DVDs in the mail to then streaming.
I mean, Netflix continued to do DVD. They do it still today, in fact. But I mean, for the first few years that I was there, the DVD was what was driving all of the profitability of the company. Yeah. The streaming was all, loss leader. But
yeah, I mean, maybe this is a good point to also explain. I think you've mentioned before in some of your talks that one of those like tenets at Netflix is this like freedom and responsibility thing where like each developer is responsible for their own code. They get to choose what they deploy, when they deploy, and if something breaks, it's your responsibility to find it and fix it, right?
Yes.
Which, I mean, I can see how that's difficult because if something does break at like 1 a.m, you can't expect your entire team to be ready at 1 a.m. for which part. And I think another thing is you expect failure. You set up the systems in a way that you anticipate things to break at some point.
Yeah. So the way that we maintained reliability was a couple of different aspects, right? Aspect one was paging the people who are responsible. And so they could, within their team, they could choose one person to be on call.
Yeah.
But we had to teach people to be on call because a lot of times it was developers who'd never been on call before. Like literally teach them, you must bring your cell phone to the bedroom when you're on call. Like we would, do incident reviews where somebody would say, why didn't you answer the page? And it was like, oh, well, my phone was on silent downstairs where I always leave it when I get home. And it's like, that's great work-life balance. But when you're on call, you need to have your phone on and next to you, like stuff like that. And so we would do that kind of thing. So training people how to be on call and, expecting that. And then the other aspect was the chaos engineering aspect, the aspect of we were constantly breaking things in production on purpose to exercise our ability to recover from and respond to those incidents. And we would do this just during business hours so that you wouldn't have to wake someone up. And nicely with Netflix, unlike most websites, the business hours do not conflict with the peak hours. Right. For most websites that cater to people who work, the peak hours and the hours that people generally work are the same hours. But in Netflix, it was switched.
Yeah.
So it was nice because we were able to do work during the day and deploy during the day and whatever, and not affect peak usage.
Yeah. Why was that a constraint? What was it constraining? I mean, it seems like and maybe I'm misunderstanding, but there's like, it seems like not scalable to teach everyone in a team as it grows bigger just to have your phone next to your bed. Like that seems difficult.
Right. So one of the constraints was when you're running a real-time service, there's this concept of nines of availability, right? And at the level that Netflix was running, even just a few seconds of downtime is already affecting the number of nines. And we did some experiments and we determined that you could get down to like 2 nines of availability without affecting retention, customer retention. But we set our goal as 3 nines. And so the constraint was we had to maintain 3 nines, which means we had to do much more automation. Because anytime you involve a human, it's immediately going to drop you an order of magnitude just based on human response times, right?
Yeah.
So the goal was always to shift away from paging and humans fixing problems to automated solutions.
Right.
That a lot of the chaos testing was around this idea of break things in production and create systems that automatically either remediate or just aren't affected by those types of outages. So automatic failover and automatic repair, stuff like that. And that was the goal, is to get to a position where everything, as much as possible, was automated so that we could not have to have a human in the loop. Because as soon as you put a human in the loop, it slowed it down. If you lost too many, if the nines dropped too low, it would start to affect retention, that affects profitability, and so on and so forth.
And also something you mentioned last time we spoke was it was difficult to find a developer who had the skills necessary that was willing to give up their like Saturday nights.
Right. So that was a tough problem as well, right? So Netflix at the time, along with the freedom and responsibility, one of the big tenets was only hire senior engineers who could have freedom and responsibility.
Yeah.
It's really hard to get a senior engineer to agree to work on call on a Saturday night. Some would do it. Some really loved it. We had a couple of really great senior engineers who loved working Friday, Saturday, because that meant that they could spend all week with their family and their kids and stuff. Yeah. But that was difficult for them because they were never around when we were there. And so it was really hard for them to integrate with the team and be involved in projects and things like that. So we wanted to get to a place where we didn't have to hire people to sit and watch monitors on weekends and holidays. So that was another goal was in our automation was to get to a point where we don't need someone watching a monitor all the time. We wanted to automate watching the monitors.
Yeah. And
so that's where a lot of the automation in the monitoring system came in. It was specifically to make it so you don't have to, that you could trust in enough to not have to have a human watching it all the time.
Yeah. And it's interesting you said that your peak hours being outside of work hours was a good thing because it meant you could work during the day. But how doesn't that mean that you have to put a lot more time into those like evening or those like peak hours outside of work, which is like,
yes,
you have to get people to stay later or come early.
Yes. So that was the downside, is if there was a problem that happened after work, it was much worse because it was during peak viewing hours for sure. Weekends, nights, holidays, those were all peak viewing hours. Yeah. So yes, it was important that another reason it was important to try to get humans out of the loop as much as possible, but also to get people really understanding what on-call means and being quick and responsive and things like that.
Yeah. Okay. So automation was obviously a solution that you pursued in this constraint.
Right. Automation is the only way you're ever going to scale an organization beyond a certain point.
Okay, and is that tying to what you said about the minute you add humans into the loop?
Yeah, basically. Yeah.
Cool. And so I think you mentioned monitoring and your alerting systems were like the first two or the two big ones that you automated?
Yeah, so monitoring was the first, and it was already kind of started before I even got there. Alerting was something that we worked on basically right when I got there.
Right.
Alerting so that you could alert on the business metrics, so you can stop watching the business metrics. Yeah.
Cool. So
and then paging people, automation of paging out to the right people. So we tied the alert system to the paging system, so you could create an alert that automatically page somebody.
Yeah.
So at least if you had to involve a human, you could reduce it was one human instead of two. Because originally it was the alert came in, one human had to process that, decide to page somebody, page them, and then another human, right? And that took a lot of time. So if we could make the alert page somebody, at least we could reduce that time. It was all about reduction of time to remediation, right? Any automation or step that we could take that reduced our time from problem happens to somebody knows about it to it's fixed was good.
And the less humans you could involve in until that final step.
The fewer humans, the
person
better.
had to,
Exactly.
Yeah. So then I'd be really keen to sort of dive into those two automation of the alerting and the monitoring for a little bit. So could you, maybe start with alerting, since that's what you were doing when you got there.
Mm-hmm.
But aside from the paging, how did you start thinking? What were some other considerations you had to work around in setting that up?
Yeah, so there was a lot of considerations with the alerting, right? One, we were running microservices, so there's a lot of services. Two, we were running in the cloud, so we had machines coming and going all the time. So all of the traditional alerting systems didn't really work very well because they were all at the time keyed on individual machines, right? And so since we had constant change, one of the first problems that had to be solved was how do you even address your alerting? Like, what do you tie it to? And so we had to figure out, we should tie it to clusters of machines. How do you keep track of a cluster? What machine is in the cluster? And so the monitoring team did an amazing job of building an entire monitoring system for the cloud. So it was designed specifically for microservices where machines are constantly coming in and out of the cluster. You don't want to have an alert every time a machine is added or removed because that's just noise, things like that. So, that was the first part. The second part was static thresholds don't really work very well. The graphs are very sinusoidal, right? So there's a peak and a trough at night during the day. And so static thresholds would not work. So we needed to figure out how to do that. And so they built double exponential smoothing into the alert system. So you could do your alerts on essentially the shape of the curve instead of the actual level. These were all things that we had to think about. Like, we're in a distributed dynamic system. Everything we know about monitoring is wrong at the time, right? Yeah. And so how do we rethink how to monitor a system that's constantly in constant change?
Yeah. Could you talk about that double exponential? That's the first time I've heard that. Could you tell me a bit more about that?
Yeah. You think of it like in your physics class when you learned about how velocity is the derivative that acceleration is the derivative of velocity, right? It's the change of velocity. So it's kind of like that. And anybody who actually knows what double exponential smoothing is going to get really angry about that I said that, but just kind of think of it like that. It's essentially a mathematical way to explain the shape of the curve and the directionality and how it's changing.
Cool. So that was the sort of like alerting thing. As you were saying, it's reducing the amount of time it takes and the amount of noise, I guess, because you don't want to, like you said, you don't alert for every single thing.
Right. You don't want to alert. And in fact, one thing that we did that actually helped a lot was every time we sent an alert, we added a little button to it that just said, was this alert useful? And the person who received the alert could say yes or no. And then we could give stats over time. This alert, 80% of the time was marked as not useful. 90% of the time, you probably want to turn this alert off. Yeah. Or they didn't even vote because they were ignoring it, right? Yeah. Or this one was marked as 90% useful. We should definitely keep this and maybe have this alert go to other people too.
Yeah.
So that was actually just getting a little bit of data from our users about the alerts actually made a huge difference.
And that was, your users there were the developers and engineers.
The developers and engineers who were receiving the alerts, yeah. One of the other really important keys to the alerts was the self-service aspect to it, where any developer could create an alert. Any developer could put metrics into the metric system. And so you could create an alert on any metric you put in or any other metric in the system or any combination of metrics. And so that was super powerful because some developers would actually want to monitor their downstream services or their upstream services and get alerts on those. And so that made it very powerful, that self-service plus that feedback loop of this is useful, this is not useful.
Yeah. And how did that help the not having to have developers stay up really late or sort of was it more like you could go to bed because you knew if something broke you would You didn't have to be there watching the thing.
That was the idea, right? Is get everybody to have enough faith in the alert system that they felt comfortable not watching.
Yeah.
And we had to get, everybody comfortable with that idea, not just the developers, but the executives and so on. We had to prove that this system is strong enough that we don't need anybody to watch this.
I mean, maybe this is a silly question, but did you have an alert for the alert system breaking? I mean, if that broke, that seems pretty bad.
Yes, we did have an out-of-band alerting system that just monitored the alerting system.
I'm not surprised you accounted for that.
Yes, yeah. We didn't account for it at first until the first failure of the alerting system, and then we had to figure out a way. Essentially, we launched a tiny version of the alerting system separately in a separate place that was monitoring the alerting system. So it was possible that there could be a failure that occurred in both at the same time since we were using the same. If you've ever looked at like how airlines maintain reliability, they usually use different vendors for their redundant systems specifically to avoid that. But since this wasn't life or death, we figured we're close enough.
Yeah, and I guess like you could endlessly build an alert system for the alert system.
Yeah, it could be turtles all the way down.
Yeah.
But
so I mean, what sort of things did you? Because obviously, like reliability of that alert system was quite a priority. Like the trade-offs of having weaknesses in that were not great.
Right.
So how did you? I mean, I guess what sort of things did you make sure would not break in that? Like, were there specifics that you were focusing on, and also how did you have like monthly or weekly monitoring of that to like make sure that it's still all working correctly? How did you sort of work around that system?
Yeah, so there was first of all, the monitoring system monitored itself. Right. In both from that external tiny system as well as internally within itself. Right. It would monitor its own statistics. It would also, we would have ways to sort of audit the alerts. So we would have like out of band systems that monitored the same metrics to see if they matched.
Mm-hmm.
But I mean, for the most part, we just sort of trusted it.
Yeah.
I mean, there was always the customers calling and telling us aspect, right? And we would definitely, so interestingly enough, the customer calls would go right into the monitoring system as a graph. The number of calls, so, if somebody called and said streaming not working, a customer service agent would press a button, that would actually go as a metric into the metric system. So we could correlate, what we saw so our main metric was play starts. The number of times someone hits the play button and successfully starts a movie. That was like the number one business metric that we monitored. But we could correlate that with customer service calls. So we could see if there was like calls rising, but everything looked okay, or everything dropped, or, we could correlate that. We could do alerts on customer service calls even because they were in the system, just like anything else.
Yeah,
and then we also did, false monitoring, right? Where we would put false data in that we knew was false and mark it and make sure it came out the other end and that kind of thing.
So, I mean, maybe I'm interested to hear what happened the first time the alert system didn't work. Like, what was the impact of that?
To their credit, I don't recall a time where we had a failure of the alert system.
Cool.
That affected us.
Yeah.
I'm sure it failed.
Yeah.
But it was never at a time where it mattered.
Sweet.
Yeah. I don't recall a single time where we had an outage and it was due to the alert system failing.
Yeah. And so something, maybe jumping back slightly, what kind of, because you said you didn't obviously want to have alerts for everything. So what kind of things did you notify people about? And maybe that like evolved over time as well into...
Yeah. So like the advice I usually give to people is monitor business metrics, not machines, because those are what your customers care about.
Yeah.
So it was mostly like each team focused on the metrics that mattered to their particular part of the business, right? So the website team would monitor website hits, and the UI team would monitor UI loads versus. So we got to cheat because we controlled the user interface as well. It wasn't a website. I mean, we had the website too, and that was harder, but it was people using apps.
Yeah.
So we could control the front end monitoring as well. We could trust the data we got from it. So we had a lot of instrumentation on all of our front end stuff. So, if you open Netflix, it would show you. So we would monitor when you open the app, when it painted the screen, when you interacted with the screen, and, every little step of the way. And so we could have alerts on everything in between.
Yeah, that makes a lot of sense. is there anything else on the monitoring side of the automation that you haven't spoken about? Because I mean, we've sort of woven the like alerts and monitoring because they are interlinked. But is there anything else? I think to remember earlier you said it would monitor screens. Is that, do you mean just like on a customer side experience, it would sort of track clicks and
yeah, exactly. On the customer experience, right? It would track when the screen started painting and finished painting, and very detailed metrics about the UI experience.
Yeah.
Which were used by the UI team for monitoring like how their development is going. Yeah. And we used it on the reliability team to monitor actual reliability. So if we saw a lot of people opening the app, but then no successful finished paints, we could alert on that, right? And say, hey, something weird happened in the UI. And then we could call out page the UI team to be like, something weird happened. Did you just deploy, whatever, something like that.
And when you said the alerts, your advice on like tracking business metrics, not machines.
Yeah.
Is that, I mean, is like a page breaking or a video stream not loading, is that a machine or?
Well, so like I said, our main metric was play starts per second, right? So a movie not starting ends up being a business metric in the respect that somebody hit play and it didn't work. So that's how it ties in. It's more of an application level monitoring, I guess, but the one that affects the business.
Yeah. And what was the impact of having those automated systems in place? Like, how did your developers and your engineering team, I guess, what was the impact on like an individual developer level of having that set up? What did it enable?
Well, I mean, what it enabled was for them to move quicker, and it let us scale the business faster than we had to scale the engineers who built it, right? Because we didn't have to hire a bunch of people to just sit and watch metrics, to sit and fix things. We didn't have to hire enough staff to cover all of the manual work involved with fixing things by having the automation.
No.
So we were able to focus on hiring engineers to build new features. And it enabled them to move faster because once they had trust and faith in the monitoring system, they felt comfortable putting new things out there all the time. We were constantly deploying thousands of times a day because we had faith that if something went wrong, we would be able to quickly figure out what and why. And that a lot of that had to do with not just the monitoring, but automated canary analysis, things like that, stuff that I didn't really work on, but had advised on, but didn't really touch personally.
Yeah. And was there did you have to rethink the way you have that like tenet of freedom and responsibility when automation became like a bigger part of that? I can see that, or from the outside, it seems like automation takes away some of the aspects of freedom and responsibility. Maybe it augments others though. So it's a worthwhile trade-off. But
if anything, I would say it increased freedom and helped with responsibility, right? So with the goal of every automated system we built was not to put a constraint on the developer. It was to make their job easier. Right. Nobody was ever required to use anything we built. Our goal was always to build something that was good enough that they wanted to use it because it made their job easier. So that was always the first test was, are people using this because they want to? If they didn't, then we built it wrong. We need to go back and try again, and we need to make something that they want to use. So if anything, it increased their freedom because it gave them a tool that made it so they could do more of what they wanted to do and less of what they didn't want to do because the tool was taking it over for them.
Yeah.
And then for responsibility, by having good monitoring, good alerting, it made it easier to take responsibility for yourself because you could put in alerts and so on and know when something that you did broke something.
Right. So developers actually also set up their own alerts for certain.
Oh yeah, for sure. Yeah, that was the self-service part, right? Is they would put their own they would write in their code to emit certain metrics, and then they would set up their own alerts for those metrics that they were emitting from their own service.
That's pretty nifty.
Yeah. So like as we move further down this path, there were whole teams that there would be an outage, they would get an alert, it would get resolved, and we'd never even know.
Yeah.
Till after the fact when they told us, hey, our system was out for a while, but like everything worked. So the main system didn't break because it just sort of sectioned them off. And like a good example is when recommendations would fail. The Netflix interface would just default to some default recommendations. You as a user would not even really know that it happened, other than maybe you would look at it and go like, this doesn't really, like, Netflix is usually better than this, but it would essentially isolate that system.
Yeah.
They would remediate their problem, and then it would turn back on, and the user would never notice. It would never affect a top level business metric.
Yeah.
And then, that whole system would take care of itself.
Yeah. I mean, the worst case scenario there is someone who is destined to watch maybe Suits.
Well, so
that night.
It would affect the business metrics.
Yeah.
In the fact that we could definitely see a reduction in streaming. So we knew that the recommendation system was very important.
Yeah. Because
there would be a reduction in overall streaming, but it didn't affect the user experience.
Yeah.
Or, I don't know how to phrase that. It affected the user experience, but not in a way that they noticed.
Yeah, they wouldn't stop using the service because of
they would maybe decide to go do something else because they couldn't find anything good because nothing good was being recommended. But
yeah, and I guess that was that something that was particularly important for you as a team, that the user experience in that case outweighed?
Oh yeah, as the reliability team, our number one responsibility was the user experience. Right, everything we did was to minimize the user noticing, right? The ideal, I have this pyramid, right, of the ideal outage. And the ideal outage was one where the user never noticed, the user was not affected, and the system remediated itself.
Yeah.
And at the bottom of the pyramid was the worst kind of outage where the user noticed, so much so that the New York Times started to call and ask because they wanted to write an article about it, right? Yeah. That was the worst kind of outage. And then everything in between was in that, in between the pyramid.
Yeah. And how did automation then fit into that sort of pyramid?
So what automation did was it pushed more things up towards the users don't notice type of events, or maybe the users notice but not enough to call us.
Right. Yeah, because things would sort of click into action automatically.
Yeah.
And then,
the more automation we had, the faster things would get fixed.
Yeah.
And the more we would. The user interface would sort of adapt automatically, and so it would affect the user, but maybe they're not sure, they notice it, but they're not sure it's working, something like that.
Yeah. And then maybe this isn't relevant for this particular thing, but something which I also found really interesting was I think you called it your monkey theory, or your simian army.
Yeah, the simian army was what we originally called it. I don't think they're even allowed to use that anymore
for
some reason. But
but did that also deal with? Because I think maybe you can start with giving a brief, just for anyone who doesn't know or hasn't seen your other talks, like a brief overview or intro into what that was.
That was basically the chaos engineering.
Right.
So it was this idea of the chaos monkey is the most famous. That's the one that destroyed individual instances in production. And then there was the chaos gorilla, which destroyed entire zones. So basically one data center at a time. And then there was the gorilla, which destroyed entire regions at a time. And those didn't actually destroy the regions. They just more shifted traffic off. But, things like that. So it was this idea of breaking things on purpose in production.
Yeah.
The other really important one was the latency monkey. And that one would introduce artificial latency between microservices, because detecting if a service is down is fairly straightforward, but detecting if it is slow is a very hard problem.
Right.
Because slow has lots of different meanings. It depends on, what you need from that downstream service. Is a 1 second response okay? Is 1 millisecond the max? It depends, right? So we would introduce that latency so services could test whether they could handle, at what maximum latency could they handle before something started to break. So it would help them narrow in on what slow meant and how to detect it.
And was that system also automated? Was that like a...
Yes. Yeah. The Chaos Monkey just ran automatically, 9 to 5, Monday through Friday. The other monkeys were automated, but we would give people warning that they're happening, and they could kind of keep an eye on their system, stuff like that. But the idea was not to cheat, right? It wasn't to get ready and do different things. It was, we're running this test, but don't do anything differently.
Yeah.
And then Latency Monkey was a test where you could set it up manually. It wasn't generally like an automatic, just random injection of latency. It was more of a targeted approach. It was, you can introduce latency between these two services, later on, it became you can tag a particular request and introduce latency all the way through the system for that one request, which was kind of fun because you could put in like your friend's personal Apple TV at their home, and they could be like, what the hell is that? We generally
Killer Easter eggs.
we generally did not do that, but we'd only do that to each other,
Right?
Not to customers,
For sure.
But mostly it was we would put a test device in a lab and say, slow down every request for this test device and see how bad it gets.
Yeah.
Where does it break? And how do we avoid it?
The reason I ask is like, having heard that, I wondered whether you had to make considerations for how that would integrate with the alert system. Because like one thing's breaking things, one thing's alerting you when things break. But you saying that it runs from 9 to 5. Did the alert system maybe kick in at a certain point?
So we specifically did not tie those systems together because when we're introducing these failures, we still want them to send alerts. So if you have not built your system to handle the loss of a server, you should get an alert for that.
Yeah.
That means something is wrong, right? So the ideal case was that you built your system such that the loss of a single server had no effect. So the Chaos Monkey would run, it would destroy a server, or something would get replaced. You'd never even know.
Yeah.
The Chaos Monkey would tell you, hey, I destroyed your thing. And you'd be like, hey, that's cool. But yeah, it was specifically like not that, right?
Yeah.
And if you're running a latency test, it was important to get the alerts to know when things were breaking.
Yeah. So the alert system, I guess, then ran 24/7. That was
the alert system just ran and it did its thing.
Yeah.
And they were specifically not tied together.
Yeah.
I mean, you could silence alerts like.
Sure. I mean, yeah.
If we were running, a big test of shutting down a whole region or something, obviously that would fire a ton of alerts and you could temporarily silence them or stuff like that.
What is one habit or mental model or framework or lesson that you've discovered that, up until now has like helped you achieve more in your day-to-day?
I think it was described by my friend just a couple weeks ago, actually, that my special skill is figuring out how something is going to break before it does, and adjusting for that. And that's been, my whole career, right, is how is this going to break? Even when I worked in security, it's like, how is somebody going to break into the system, right? When I worked in reliability, it's how is the system going to break? When I worked at Reddit, it's how are people going to try to cheat on Reddit? Like, it's always been a matter of how are people going to break the system, or how is it going to break on its own, and what can we do to prevent that from happening?
I mean, that seems quite closely related to like QAing and user testing and stuff like that.
Yeah.
Very cool. And finding weaknesses of the thing always helps you. Help you better it and make it more robust.
Right. Cool. Yeah, and like even when my very first job, when I was just in IT, we were running the product, and so. Like I was constantly finding, hey, this doesn't work, or this is going to break, or stuff like that.
Otherwise, like where can people, if they want to follow you online, like do you have I know MinOps has a website, maybe you can also give some insight into what that's all about. But like where can people follow you online, social media, that kind of stuff? Yeah,
so, you can follow me on Twitter. I don't tweet all that much. You can follow my LinkedIn. I don't use that right now very much, but I'm going to start because everyone keeps telling me I should.
Cool.
I don't really have a good way to follow me, I guess. I'm not so good at marketing myself, I suppose.
Yeah.
If you follow my Twitter, Google my name, you'll be able to see the stuff I've done and all my other presentations on YouTube or wherever they're online. Stuff like that.
Sweet. And what does MinOps do? Like, what is
so MinOps is my company now, and we make a SQL interface for your Amazon metadata. So basically, anything that you can get via Amazon API, we present via SQL. So machines, IP addresses, all that kind of stuff.
Super. Well, yeah, I hope anyone who's interested in that will go check that out.
That's pretty cool. And you can get to that by going to sql.bot.
Amazing. Sweet. Well, yeah, thank you so much for sharing all your insights into Netflix. Like I said, we can probably have many more of these conversations, which I'm really keen to do. So hopefully have you back on the podcast soon. But otherwise, I
may have to record that from California, not fly to South Africa.
We can arrange that. Maybe I can come to you that time.
We
perhaps. Can do it that side. But otherwise, thanks so much for sharing your insights.
Thanks again for having me and bringing me out to South Africa. I'm loving it so far. So it's been great.
Cool.
Thank you.
Fantastic, dude. Thanks.